Having one normalized vector, we can take the dot product with the surface normal, dot from the normal and the half vector, and if this result is positive, then we'll return the dot product to the power of the glossiness multiplied by the specular level. Otherwise, we're going to return 0. Now that we have this function, we'll call it from inside of the fileArray function. First, we'll need a variable to accumulate the colors of all the specular highlights of all lights that we are processing. Let's define a variable called the spec lighting and set it initially to black. Then inside the for loop for all the lights, for every single light, let's add the result of the function call to our highlight function to the spec lighting variable. We call the function and pass the material definition element number 5. As you probably remember, the 5th element is the specular level, the 4th is the glossiness, the 3rd is the specular color. So we pass the 5th, the 4th, then the surface normal, which is the intersection element 1, the direction of that ray. Then we need the light ray, which was calculated earlier for the diffuse shading. And finally, the inverse of the view ray direction, which is the view ray from the point of intersection back into the eye. Having calculated this value, we can multiply it by the light's RGB color. Finally, after calculating the surface color, we can say if the material definition with element 5, this is the specular highlight level, is greater than 0, then we can add to the last surface color, which was already shaded to the diffuse color, we can add on top of the diffuse color the specular highlight using the material definition element 3, which is the specular color of the surface, multiplied by the spec lighting, which is the sum of all the specular highlights of all the lights that we processed earlier. Now that we have implemented all this, let's set the material of the teapot to have certain specular level and glossiness, and we could also assign a different material to the sphere and use a specular highlight of 50 and a glossiness of, let's say, 30. We can also change the color slightly. Now, if we would evaluate this script, we should get an additional specular highlight on top of the diffuse shading. We can also try to change the color of the light to, for example, red, in order to see how the specular highlight is being reflected because of the multiplication with the light color. As you would expect, the specular highlight is using the new color of the light source. Of course, we can create another light source in the scene, move it somewhere else, for example, somewhere on the side here, and try to render again. As expected, both light sources are being calculated correctly, and we're getting two specular highlights on both sides of the object.